Hello, hello, Grid Investor Network. I'm Danielle Palloschi-Browne, an investor agent, and I'm here with my partner, Raj Tamang of Green Valley Custom Builders, and we are here today to continue our architectural plans series and conversation, specifically how to read blueprints. And today we're going to talk about elevations and different segments of architectural plans and permits. So, Raj, where should we start with this?
Okay. So last week I think last time, 2 weeks ago, I think we didn't do last week, right? We missed last week.
Yeah.
We talked about the floor plans, architectural floor plans, right? House floor plan, basement plan, first floor plan, second floor plan. But so today we will talk about the elevations, building elevations, how the building looks like from outside.
Yes.
So what type of finishing you put outside, what kind of information you have to show on the plan. So the permit, get the permit. Also, the contractor on the side can understand what to build. Also, if we have a time, then we'll talk about building sections. The sections means you will see the details of the wall sections, how the wall are built, what the floor systems are, if there's I-joist, the 2x6, 2x4, what kind of insulations. That information will still show. The insulation part is still part of the architectural, but the framing part, the joist and beam and 2x6, 2x4, that's like structural.
Got it. I think we've seen little components in other episodes that we've done, but we're going to really do a deep dive on that to really kind of break down, like, what are you looking at in this little section, this subsect that's broken out. Okay, great.
So after this one, so this would be a continuation for several weeks, I assume. And when we talk about the structural, then we'll show you exactly how those framings are done, correct, on the site. This is we talked about this one before. Architecturally, it's mostly how the building will look like, but it's not really how it is built, how the nails are put, how the concrete walls are poured, how the footings are poured, how the rebars and reinforcement on the concrete walls and footings are installed. Those details are part of the structure, which is coming. So we'll see how detailed we can go, but this is still part of this architectural, how the building look like from outside and inside.
Got it. So, and this is really like there's a lot of different types of elevation plans, or what can look like different elevations. Like I've seen ones that look just like a house, almost like a photograph. So like digital renderings. And then there's ones that are much more specific to, like, they look more like a blueprint. So what would you say, what is the biggest difference there, or why would you have two different elevation plans like that? Like one that's a little bit more artistic versus one that's a little more mathematical, maybe, for lack of a better word?
More like technical. Yeah.
Yes.
If you don't mind, let me share my screen, which I think I can share my screen. Okay. Entire screen. Share. Okay. It's not sharing. I just did it. I mean, it says, okay, entire screen. Okay, that's it.
Yes, here, I'm going to add this.
You see it now.
Perfect. Yep. So
this is the house we are actually looking at. Okay, the floor plans and all that. So this is you can see it, right? So this is the rendering part.
Yep, the very artistic part.
Correct. So you don't have, this is not a part of the permit documents, but if you have rendering, it's really helpful to understand how the building will look like from outside, right? You can also do renderings for all the interior layouts and details, but mostly if you have outside, it helpful, right? So this is a rendering. This is the back side. You know, here on the first list, we go back, so you'll see this is a stone and a stucco. So my front elevations, I have a stucco and a stone. And other elevations, I have a hardy siding, cement board. So now going back to the plan, so these are what the elevations look like. So these are, you have to remember, all this is mostly, it's all 2D, right? Two-dimensional. So this is the front elevations, means how the building will look like looking house in the front plane, right? Front elevation. So this is just a two-dimensional.
Yep.
On this one, some of the things you have to understand. See, these are the garage. So double car garage, single car garage. This is a front door. We have a big windows. And this is a stone. So indoors, I think the stone siding, the hatching is not that great, but at least you know we plan to install the stone on this side, right?
Yep.
Then this is all we're calling out stucco siding. So all these things you have to detail. So I have a 2-foot cantilever roof. This is a flat roof. Then also you have to see all the vertical dimensions. All those horizontal dimensions you show on the plan, but any vertical dimension, building height, you have to show on elevations. So this says, okay, this is the first floor. The windows, top of the windows are 8. So I say this house, the first floor is 10-foot ceiling. Second floor is 9-foot ceiling. So since the first floor is 10 foot, all the doors are 8-foot doors. Okay, I'm using 8-foot doors, and also the front elevation windows are 8 foot. Not all of them, but at least front elevations are 8-foot windows. So you have to tell them where they have to install the window, right? That's what you say, 8 foot.
Yeah.
Then this is the second floor. Is, you know, from here to here. I'm saying first floor is 0. So the top and top of the second floor is 11 foot 2 3/4. If you are wondering why this odd dimensions, is because my floor height is 10 foot. Then I have a floor joists are 14-inch floor joist and a 3/4 inch plywood.
So it's a whole space. Yeah, so it identifies everything in between those spaces, like in the ceiling and under the floor.
Correct. That's including the thickness of the floor system, all of that, the joist and plywood, all that. From there on the second floor, 8 foot, and same thing here. So roof ceiling is a 9 foot, so 11 2 3/4. So roof height. All this information you have to show on the front elevation. Now you say, hey, I have a mean roof height is 28.31. You're wondering, how do we get this one? That depends. This is in Fairfax County. You have to give them a mean roof height, which means that if you look at this one, I have a full basement here, but the basement is fully buried, you know? So it's fully buried basement. Also on the back side is also kind of buried basement. This is not a walkout basement. This is walkout basement. So the civil engineer is the one who does all these calculations, math, calculate. So this is average grade level that's what the civil engineer do, math based on the grade around the house, and they will calculate the average. And from there to the roof, mean roof height, okay, not to the top of the roof or not to the lower level. So in my case, because I have some tower and I have this is the main roof, right? This is the main roof level. This is a tower, 2 towers here. So I'm taking the average height, which is here. And that dimensions, you have to match with the grading plan, because grading plan, civil engineer is the one who will calculate that height. And this height in Fairfax County has to be less than 35 feet.
Mm-hmm.
Okay. So that information, yeah, you put that. And I'm calling out front elevations. So this one, it's a rear elevations back. And also I'm saying the scale, okay? This is very important. You have to indicate the scale you drawn on this floor. These plans are 24 by 36 inch. So 36 inch wide, 24 inch height drawings in scale, quarter inch per foot, right? So if you look the back side of it, you'll see I'm saying this is a PVC corner trim, RD plank siding, PVC fascia. So on the back side again, so I have 8 foot is the top of the window, but the second floor is only 6'8". Because 6'8" is pretty standard for all the windows and doors. Standard doors is 6'8", which is 80 inch, right?
Mm-hmm.
And the idea is when you install the windows, try to match. I mean, I would say almost all the time, the top of the header of the doors and the window you should match.
Yeah, so if you have 8-foot door, because it creates a consistency in the design.
Correct. So that's why on the first floor, since all my doors are 8-foot doors, so I'm putting all the window header at 8-foot level. But on the second floor, all my doors are 6'8", so my window headers are 6'8". So that's
so they'll line up.
They line up exactly. And same thing here, mean roof height. And what else? We have a covered porch. So our railing system we have to show. So here we have area way going down to the basement. So when there's an area way, we have to have a railing for safety. And also on the front, so you have these steps here. This is the front door. So you don't see a railing here, but if this is a concrete front porch, the porch height from the outside gate is more than 30 inch, then you have to have a railing for safety. So in this case, you don't. So just magic number is 30 inch. So if it is less than 30 inch, you don't have to put a railing. That also applies to the deck and patio on the back.
Got it. So anything taller than 2.5 feet, you have to have a railing.
Yeah, from the ground, exactly. If the deck is only 2.5 or 30 inch. So this is what happens. I mean, if you have a 30 inch, if you don't have a railing, and safety wise, if you have little kids, I would be concerned, right? I would probably still put a railing. But
sure, yeah. I think a lot of people probably still would put a railing. You just don't, you're not required to put a railing.
Correct. But if it is less than like 12 inch or so, I don't think you have to, That's more like, not, sometimes the code compliance doesn't mean it's a convenience, but the front elevations, you have to remember if it is 30 inch, this is not a really front porch. You sit there and enjoy at the front. So this is more like transition going from outside to inside. So if it is less than 30 inch, you don't have to comply. You don't have to have a railing. I would not put a railing, because if you put a railing, maybe elevation will look a little bit different, right?
Yeah.
I'm trying to get this very clean, modern look, very simple, which means that less details are better.
Less details are better. Well, and that also helps with the permit reviewer.
Correct. Less details, and also that means that trims, right? I don't want to put, nowadays in modern homes, the reason I like it, like no trims, inside the house, the only thing you see is baseboard. Is very simple, which I like it. You don't have to do, if you go the old details homes, big homes, if you go inside the trims, the detail you see, like sometimes so much, it's so dizzy, It's
Yeah, like the
too much on the
3
surface.
different pieces of trim to make a crown molding. And you're like, what? This just took so much effort.
Yeah, it takes so much effort. I mean, I'll show you quickly. I'll show you here from our house. Then they will quickly see in terms of detail. No, 10. Okay. So they will get a little bit of idea of, and this. So this is the house we just finished, right? So when you look at it, this is how it's gonna look like it. See, I'm not putting railing here. This is already done. So you have a stone and a stucco, black and white, very clean. Like this. There you go. And when you go details inside, like I said, this is probably outside patio. Inside, man, we have too much outside. See, you come in here, it's very plain. It's nothing there, you know? The only thing you see is front molding, very simple. That's a mod. So you have to kind of see with it what type of design you're going with, modern or, you know, semi-modern or craftsman style. So that all depends on your design and the style of the house. So that's that. This is the first floor. What is the second floor? Where you go? What is this, man? Okay, right here. That's what I was hiding. So these are the elevations on front. So you have to have a port side elevations of the house. The reason is sometimes you might need a 5 if the house is too big and the shape is not so much of a regular square or rectangle. Then you might have to have a more than 4. But typically 4 is fine. You know, looking front, left and right, and back. Then this is the building sections. Then you also have to cut the section of the building in 2
like
directions.
cutting it right down the middle. Like if you took the back off, this is what you would say.
Correct. If you cut it right through it,
this is what you'd say.
Yep. Correct. If you cut it right through it, that's how it's gonna see it. Right. And typically you need a 1. 1 is going left and right, and the other one is going on the top and bottom. Or it's called a longitudinal section and transverse section. So this is how, like you said, it'll look like. So this is all a basement, concrete wall, you know, floor system, and these are the roof trusses. And I'm gonna go to the detail. So it depends where you cut the section. So this one is, you have to remember 8. So the way it is go is, I'm looking at the section 2A.7, right? This is the second section. You cut it right through it. And this arrow means you're looking from bottom to top. This is arrow, direction of the arrow. Yeah.
Got it. Okay.
So I'm cutting the section right here and looking up. So whatever I cut it, or because when I cut a section right here, I'm cutting section right through the stairs, and the backside I still see some of the doors, right? We show that. See. I'm cutting right through the powder room and the door. All this one, you have to cut it. So that's the direction. Cut the section looking up. And other direction is here. You cut right through it, and you're looking right to left. I'm going to go to the sections again. That's how you see it. And so these are some of the details you'll see. So these are the details you'll see how these walls are built, right? These are the footings here. See continuous footing, see structural. So because its footing is there, but the footing information is not there. So it is referring to the structural drawings. Then you have to have outside, the inside. Then you have a weep holes every 8 foot on center. Again, the idea is you collect this drain pipe will collect the water from outside the building, and weep holes we take it inside, collect it inside, and from here it goes to the sump pump. So here you see this is concrete wall. I'm saying waterproofing concrete foundation wall for structural 2x4 struts, R13 bat insulation. There's R half-inch gypsum board. All that information here. You're probably wondering why you don't have it on this side, because this is utility room. In the utility room, you don't have to have it. You don't need it, right?
Yeah, because it's not considered living space.
Yeah, correct. So on this,
it's unfinished space.
Excuse me. Yes, that's part of the unfinished space. So here on the detail, you'll see this is not probably correctly done, but there's a seal plate, continuous pressure-treated seal plate, anchor bolts, and then you have a continuous rim board, because this shows eye joist, 14-inch floor joist, eye joist, and there's a tongue and groove OSB subfloor. So all that details are here, and here is this one.
What?
Correct. And you go here 2x6, R15. We do R19, but R15 is what is required minimum, based on IRC 2015. So R15, same detail going up, up, up. This is a window header. So some of the details, for example, because I have a cantilever, 2-foot cantilever details, so I'm putting the details here, showing, all that needs to be framed, soffit detail. And since you have a stucco, you have to put some detail like this. So how the stucco needs to be installed. So that detail is there. So that's about it on the architectural part of the elevations and sections. Danielle,
awesome.
Can you think of anything more?
No, I can't. I think it's very important when you're reviewing plans, or say you're collaborating with an architect, or you're working on a project of sorts, and say you're not as familiar with this. So say, like me, I'm not an engineer. I wouldn't be writing up these plans. I wouldn't be drawing these plans myself. It's important to get an idea of what's happening here. You want to look at both the longitudinal plans that, like you'd said, like slicing it vertically, versus, is it called latitudinal if you go the other direction?
No.
Horizontal plan, or like your cross-section plan?
Yeah, cross-section transverse.
Transverse. So it's really looking at both perspectives really gives you a great idea of not just where things are, but how things are existing when they're being installed. It gives you much more of a three-dimensional understanding of both. So you really do need both of them in collaboration with each other.
Correct. And I'm going to just type it here, IRC 2015. So this is the code.
The building code. International building code, right?
International building code that governs the design. It's coming to me. So this is the one you have to buy it. International Residential Code. The IBC, I say IBC, International Building Code, that's for commercial. So this is for International Residential Code. It's for the single family residential construction. And if you have a designer or architect, you have to have that. And in Fairfax County, they use it, but if you say, they call it Virginia Residential Code. And if you type it, so look at this one. They already have a 2018 now, but so the Virgin Era, they have adopted their own code called Virginia Residential Code, but guess what? They copy pretty much everything from IRC, like International Residential Code, and they tweak it here there because our climate conditions or geology, it's slightly different, right? It's not the same throughout the country. So they kind of modify slightly. Some of the things I can give you the difference. If you have a house you're building in Florida versus here, it's different because there you have to worry about high wind, but not so cold, right? Not cold. So you don't have to worry about the frost depth so much. Means you probably 8 inches or 6 inches below ground is fine. As long as your ground is firm, you can just pour the footing like 6 inches, 8 inches below ground. That's it. But here in our side, because of the cold weather, you have to maintain, at least in our area, and Fairfax is at least 24 inch. In DC, we usually do 30 inch. Maryland's about 30 inch. Go New York, about 36 inch. As you go more colder area, so you have to go more deeper, right? Those are the additional requirements they have on the code, but pretty much they just adopted IRC and slightly modified per us. So even if in Virginia, if you say I designed per IRC to the IRC instead of Virginia Residential Code, you won't be wrong. You are still okay.
Yeah, that makes complete sense. Awesome. Well, again, this has been really helpful. And I know I learned a lot because even just some of the keys that you learn as you kind of look more at these, like what are these meanings or what does this stand for? That's really helpful. And as someone who is never going to write one of these myself, it's very helpful to be able to know how to read the book, if you know what I mean.
Right.
So thank you very much for sharing this. And I'm excited to next week jump into additional information about the structural segments. And we're going to go deep into that. So if anyone has any questions about that for next week, please do leave it in the comments and we'll see you guys then.
Sounds good. Thank you. Bye-bye.
Awesome. Thanks. Bye, Raj.
This is a long weekend, right? It's supposed to be. I'm not supposed to work this weekend.
It is a long weekend. Enjoy your Memorial Day.
Yeah, you too. Okay. Bye, guys.
Bye.